Okay, calculus, we are back. And specifically, we are ready for example number 9. Now here is where we're going to get into some very calculus-y sort of terms. So just pay attention, and if you need help, please ask in class. So we begin with question number 9. Number 9 is, what is the limit as x approaches 0 of x cubed plus 12x squared minus 5x all over 5x? And the first thing we're going to try here is to just do a simple substitution of x equals 0. So we get 0 cubed plus 12 times 0 squared minus 5 times 0, and hopefully you see this whole thing will equal 0, and 5 times 0, and hopefully you'll see that equals 0. Unfortunately, we get 0 over 0. Now this is what is called an indeterminate form, which basically means we need to do something else to get to an appropriate answer, and there are just a myriad of things that we can do here. So and I will try and take you through several examples of how can we do different sort of things to come up with an actual answer, because 0 over 0 is no good. I mean, that doesn't give us an answer. So the first thing I'm going to look at is this original problem. If I look, okay, I could factor out an x up here. So I can factor out x and be left with x squared plus 12x minus 5 all over 5x. And notice now that I can cancel out the 5x's there. Now realize we still haven't taken the limit yet, so this is actually the limit as x approaches 0 of this whole thing. But now we have a little bit simpler problem. So now let's try a substitution. It now becomes 0 squared plus 12 times 0 minus 5 all over 5. And let's see, what does this equal? Negative 5 over 5, which equals negative 1. And all of a sudden we have a limit. It's not 0 over 0. It doesn't break the rules of mathematics. And so our limit is actually negative 1. Now one thing I do want to point out is you have to carry this limit, this LIM here, until such time as you do a substitution. As soon as you do the substitution here, you no longer want the limit as x approaches 0, because you are using one of several methods to determine what the actual limit is. So make absolutely sure that when you do this, if you haven't substituted in yet, make absolutely sure you put the LIM, the limit, as x approaches whatever or h approaches whatever. Just do that and life will be a whole lot easier. Example number 10. The limit as x approaches 3 of x squared plus 6x minus 27 all over x minus 3. Well, guess what happens? If you plug in 3 here, 9 plus 18 is 27. 27 minus 27 is 0, and even worse yet, 3 minus 3 is 0. So we're going to get 0 over 0 if we do just a simple substitution. So what I'm going to look at is, can I factor anything here? Well, I can't factor out a common factor, but I can factor out, or I can factor that numerator. And this numerator factors to x minus 3 times x plus 9. Now if we look carefully, notice this x minus 3 will cancel with that x minus 3, leaving what is the limit as x approaches 3 of just plain old x plus 9. This is a very simple substitution. 3 plus 9 equals 12. And there is our limit. Versus the 0 over 0, which was the indeterminate form that we had before. Continuing with example number 11, we have the limit as h approaches 0 of x plus h, the quantity cubed, minus x cubed, all over h. Now, very quickly, we would get a 0 here, and x plus 0 is x. X cubed minus x cubed is always 0. 0 over 0. Indeterminate form if we just try a simple substitution. So what we need to do is we need to work with this and try and work on something just a little bit better. So x plus h, the quantity cubed. Now this may not be quite so straightforward, but this is what it equals. X squared plus 3x squared h plus 3x h squared plus h cubed. That's what x plus h, the quantity cubed, equals. Minus x cubed all over h. Now notice we haven't substituted in 0 in for h, so I need to hold this limit until such time that I actually put the value of 0 in for h, at least if we're using substitution. So now let's see what happens here. X cubed minus x cubed. Well, they cancel each other out. Then we're left with 3x squared h plus 3x h squared plus h cubed. But I look at that and say, I know for a fact, I don't know why I underline the limit, I know that I can factor out the common factor of h. So I pull out h and get 3x squared plus 3xh plus h squared all over h. And notice, lo and behold, those h's cancel each other out. So now we might actually be able to substitute in directly because we no longer have this 0 in the denominator to worry about. So let's see what we get. 3x squared plus, well, 3x times 0 is 0. Plus, well, substituting in for the h here, 0 squared is 0. And 3x squared plus 0 equals 3x squared. Now, is it okay to have 3x squared as the answer? Absolutely. You know, you should be well beyond that, oh my gosh, I need to have a number. No, algebraic expressions are perfectly fine. Okay, let's look at number 12, example number 12. We're told that the limit as x approaches -4 of f of x equals -5. And the limit as x approaches -4 of g of x equals 3. And we are asked, what is the limit as x approaches -4 of f of x times g of x? Well, limits follow pretty much the same rules as any other sort of function you know, that we've seen in years past. So basically all we're going to have to do is we're going to have to take, okay, what's the limit as x approaches -4 of f of x? Well, according to the problem, that's -5. Times, what's the limit as x approaches -4 of g of x? That is 3. -5 times 3 is -15. And that would be the answer to number 12. Number 13 asks, what is the limit as x approaches 6 of f of x plus g of x, that whole quantity squared? And we're given the limit as x approaches 6 of f of x and the limit as x approaches 6 of g of x. And so all we have to do is basically plug it into this expression. We're doing a substitution, but we also have to do several other things in order to get the final correct answer. And so here we go with this. First of all, what's the limit as x approaches 6 of f of x? According to the problem, that's -4. What is the limit as x approaches 6 of g of x? That's -9. So it says to add right here. So add -9, and then we're going to square the whole quantity. -4 plus -9 is -13, and squaring that whole quantity we get 169. So the limit as x approaches 6 of this monstrosity here equals 169.